Okay, now let's solve a problem of finding out deflection at any point in a truss. Okay, so I am solving a problem from the book S. Ramamrutham only, a very easy problem, and you can do other problems also. If you get any doubt, then you can ask me. Okay, so the first question is like this. This is a truss and this sides are fixed. Okay, this is point A, this is point B, and this is point C. The angle is theta and a load of 120 kilonewton is applied here. Okay, so in the question it is asking us to find vertical and horizontal deflections of the joint C of the truss shown in the figure. The area of the inclined tie, so area of AC is given as 2000 mm square, 2000 mm square. Okay, and the area of horizontal member is 1600 mm square, so area of BC is given as 1600 mm square. Okay, and the given is modulus of elasticity E is 200 kilonewton per mm square. So E is constant for both the members. Now we need to find out deflection at point C. Okay. So in the first step, we need to find out the member forces. Member forces in member AC and BC. AB is not a member because this is fixed, so there are only two members. Okay, so for solving this type of problem, let's find out tan theta. What will be tan theta? The length is given, this length is 4 meter and this length is given as 3 meter. Okay, so what will be tan theta? So this will be 3 by 4, apart from 3 by 4. What is sin theta? Will be 3 by 5. What will be cos theta? This will be 4 by 5. So we have values of tan, cos and sin. So to find out the member forces, we have to resolve all the forces in horizontal and vertical direction by considering the joints. So let's consider only one joint is there, joint C. So joint C, if we resolve vertically, or if I draw it, so joint C, there is one member BC, so this side this will be P. So this is member force in BC which is acting this way. 120 kilonewton force is acting downward, and there is the member PAC which is at an angle of theta. So if I resolve it, along this direction one component will come, and along this direction one component will come. So how much this will be component? PAC, this will be sin theta, and this will be PAC cos theta. Okay, now we have resolved it. If we apply the equilibrium equations now, what will this PAC cos theta, PAC cos theta plus PBC is equals to 0. So from this we get PBC is equals to minus PAC cos theta. So there are two unknowns. So these are the horizontal components. Summation of horizontal force equals to 0. If I apply summation of vertical force equals to 0, what will this will be? PAC sin theta is equals to 120. So from this we get PAC is equals to 120 divided by sin theta. Sin theta value is already there, 3 by 5. So 120 into 5 by 3. So 200 kilonewton. Okay, so we got PAC. Now if we put this here, we get PBC is equals to minus 200 cos theta. So this will be minus 200. What is the value of cos theta? 4 by 5. So 5 गुणे 4 16. So this will be minus 160 kilonewton. Okay, so this is negative, so this will be compressive in nature. Okay, and this is tensile in nature. Okay, so we got the member forces PAC and BC due to the external loading system. Now what we will do, we apply unit force where the deflection is desired. So कहाँ पे apply करेंगे? So let me draw the figure again. So this is the figure. Okay, so this is A, B, C, length we already know, this is theta. Okay, so we are applying a unit force at point C, kitna 1 kilonewton. Okay, now due to application of this 1 kilonewton force, we have to find out the member forces. Kya? Let's consider this, the member forces is KAC and this is KBC. Okay, now if I draw the free body diagram at joint C, तो क्या होगा, along this direction there are KBC and 1 kilonewton force is acting this way. One component of AC member will come this way and one will be this way. So KAC sin theta will be acting here and KAC cos theta will be acting here. Okay, again we apply the equilibrium equation. So applying summation of vertical force equals to 0, क्या होगा, KAC sin theta is equals to 1. So from this we get KAC is 1 by sin theta, so 1 by 3 by 5, so this becomes 5 by 3 kilonewton. Okay, positive is coming, so this is tensile in nature. Now if I apply summation of horizontal force equals to 0, what will be the equation again? KAC cos theta plus KBC is equals to 0. So from this we get KBC is equals to minus KAC is 5 by 3 cos theta. So what is cos theta value? 4 by 5. So it is coming 4 by 3 negative. So minus 4 by 3 kilonewton. This is compressive in nature. Okay. Okay, so now we need to draw a table where all the member forces we can write. Okay, so let's draw. So first is member, next is P, next is K, next is length and area. Modulus of elasticity is constant for every member, so the term is not required. Okay, so the last one is PKL divided by AE. Okay, so first is, let's consider member AC. So member AC we have already got two forces. For member PAC we have got 200 kilonewton. Okay, so I will write here 200 kilonewton. Okay, member, कौन सा member? BC. For member BC we have got the member forces minus 160. So minus 160. Okay, now for member AC the value of K 5 by 3. This is minus 4 by 3. So right here 5 by 3 minus 4 by 3. Okay, now length of each member कितना है? Length of AC is 5, length of BC is 4. So length of AC is 5, length of BC is 4. Okay, now cross sectional area of member AC. So member AC cross sectional area is 2000 mm square, another is 1600 mm square. So this is 2000, this is 1600. Okay, so now this is area is in mm square. Okay, modulus of elasticity unit is Newton per mm square. Okay, and these are taken in kilonewton and length is taken in meter, so we have to change this to mm, so this is 5000, this is 4000 okay. Now we need to find out these terms, okay. pkl by ae, so we have to do the calculations now, okay. So as is constant for every member, so we'll divide that at the end. So after calculation of this term pkl by a, we will get this as 2500 divided by 3, and we'll get this as 1600 divided by 3, okay. So by adding this total will get as 4100 divided by 3, okay. Now vertical deflection at C, yc can be written as summation of pkl divided by ae, okay. So we'll divide e with this term, so this will be 4100 divided by 3 into 1 by e. E is 200 kilonewton per mm square. We have already found out this. So load is taken in kilonewton and other terms are taken in mm square, okay. So now if we solve this, we will get 6.83 mm, okay. So this is, we got vertical deflection. Now we need to find out the horizontal deflections also. So if we need to find out the horizontal deflection, we have to apply a unit force along the horizontal direction, okay. So how? So let's draw me a figure again, okay. Now this is the figure, okay. We already know the lengths, okay. This point was B, this is A, and this is C, okay. So we need to apply a unit force 1 kilonewton. Direction can be anything, it will not matter, okay. You can take in any direction. So if I apply 1 kilonewton along this direction, so we need to find out again the member forces due to application of this 1 kilonewton load, okay. What will be this term? This is KAC and this is KBC, okay. Now if I draw the free body diagram again, this will be like this. How much? So there is a force is applied along this direction, joint C, KBC, okay. Two components of AC, so KAC sin theta and KAC cos theta, and a unit 1 kilonewton force is applied here, this is 1, okay. Now from this summation of vertical force equals to 0, we get KAC is equals to 0. If we take summation of horizontal force equals to 0, then we'll take KBC. KAC is already 0, plus 1 is equals to 0. So we get KBC is equals to minus 1 kilonewton, which is compressive in nature, okay. Again we need to draw the table, okay. So here I'm going to draw the table because one force is already 0, okay. And we need to find out the horizontal deflection, okay. Deflection of in horizontal direction, okay. Again the same formula, summation of pk l by ae. So this will be PAC into KAC, length of AC, divided by area of AC into E, plus force of BC, KBC, length of BC, divided by area of BC into E. So as KAC term is 0, so this term becomes 0, okay. What is PBC? We have already found, minus 160, so minus 160. KBC we have got minus 1, okay. Length of BC, how much we have got? 4000. So 4000 divided by area of BC 1600, okay, into E is 200, okay. So this is at 2 mm. If we do the calculation, we will get the horizontal deflection is 2 mm and vertical deflection is 6.83 mm. Similarly, we can solve other problems also. So I will give you some problems, you try on your own. If you get any doubt, then we'll solve it, okay.